what is value of I, square root of I? So today I am going to solve what is value of square root of I. I is a complex number, everyone knows, okay? Complex number. In the complex number we have I square equals to -1. So there is a relation between Cartesian coordinates and complex coordinates, or you can say polar coordinates also. So let's find out what is value of I, square root of I, okay? Let square root of I be equals to a plus ib. Why a plus ib? Because it is of the, any complex number is of the form a plus ib for all a, b belongs to integer. Okay, here I square is, we have -1. Okay, now let's square on both sides. Squaring on both sides, if I squaring on both sides, we have, so if I square on both sides, this will, here I the whole square is equals to a plus ib the whole square. Okay, this implies it is only from a plus ib the whole square, a plus b the whole square. Here a square plus twice ab, okay, twice a into ib plus ib the whole square. It is same as a square. Here we have imaginary number I over here. Okay, so I will bring I over here, plus I can write I into 2ab here, plus here I square into b square. I square is what we have, -1. Therefore it will be minus of b square. On the right hand side, what we have is square root and square gets cancelled. We have I is equals to a square plus I into 2ab minus b square. Now in this equation, let's compare with real and imaginary parts. On the left hand side, what we have is, we have only I. Okay, I is, we can written as I is same as 0 plus 1 into I. Okay, is same as, it is of the form complex number. Any complex number is of the form a plus ib. So this is real part, this is imaginary part. In imaginary part is associated with I. Here nothing is there, so we can write as a 0. Okay, here I is same as 1 into I. Here real part is a square minus b square. I can write like this. I can combine these two, plus I into 2ab. Okay, now let's compare real part and comparing real and imaginary parts. Here real part is over here on the left hand side, real part is 0. On right hand side, a square minus b square. Why? Because this is free from I. Okay, these are all free from I. Therefore 0 equals to a square minus b square. On other hand, here what I have is, on left hand side I associated is what, 1. 1 equals to, here we have on right hand side 2ab. Here, from here I can find out, I can send 2b here, 1 by 2b equals to a. 2b I can send down. Here 1 is over here. I can put this value of a over here. Okay, it implies I am putting the value of a here. 0 equals to a is 1 by 2b the whole square minus b square. It implies I can bring b square over here. B square is equals to 1 by 2 to the 4 b square. It implies I can multiply this 1 by 4 b raised to 4 is equals to 1. It implies 4 b raised to 4 is equals to 1. Cross multiply. Again let's bring over here. 4b raised to 4 equals to 1. 4b raised to 4 minus 1 equals to 0. Okay. It implies 4 I can write like is 2b square raised to square minus square equals to 0. 1 I can write like is 1 is same as 1 square. Let's check over here. 2 2s are 4. Okay. B into b square plus b square is what? B raised to 4. 2 2s are 4, b raised to 4. Okay. It is only from a square minus b square. We have a square minus b square is equals to a minus b into a plus b. Okay. Here we have a is 2b square minus 1 a square minus b square. It implies 2b square minus 1 into 2b square plus 1 equals to 0. Either this into this equals to 0. It means either this equals to 0 or this equals to 0. This implies 2b square minus 1 equals to 0 or 2b square plus 1 equals to 0. It implies 2b square equals to, bring that side, equals to 1. It implies b square equals to 1 by 2. It implies here I have to take square root on both sides. So it will be plus minus b equals to square root of say square root of 1 is 1. So plus minus 1 by root 2. Okay. Similarly over here 2b square equals to minus 1 is implies b square equals to minus 1 by 2. Here minus 1 is I can write is I square. We have I square is minus 1. So instead of this I square upon 2 is b square. So if I take square root on both sides, b is equals to here square root of upon square root of 2 I square. So here we have square root I gets cancelled, plus minus I upon root 2. Now putting the value of b in, I can put one of this, either this or this. Now we have b equals to plus minus b equals to plus minus 1 by 2, and we have these two relations. Okay. So now we have value of b here. From here you can say 1 by 2b equals to a. It implies 1 upon 2 into 1 by plus minus root 2 is equals to a. So I can bring over here, it implies plus minus is equals to a is equals to plus minus this 1 upon 2 root 2. I can bring up over here plus minus root 2 upon 2. This is value of a. Okay, substitute over here. A is what? A is, we have plus minus root 2 upon 2 plus, what is b? B is plus minus I 1 by root 2. Or here otherwise we can generalize this by taking LCM.